So before start the real numbers, let us recall that natural numbers. So as we know that natural numbers starts from 1.
1, 2, 3, up to.
Then if you include 0 to the natural numbers, then we get it as
Sir, your voice is low to hear.
okay. Natural numbers include with 0, then we'll call it as whole numbers. Whole numbers are included with negative numbers. Then these are called, what are those?
Integers.
Next, using the integers, we can define the rational numbers. So if the number is in the form of p by q, q not equal to 0,
Zeros.
p, q are integers.
And it's real numbers.
Those are real numbers,
Yes.
isn't it?
Yes.
These are rational numbers. These are rational numbers. The numbers which
Yes,
cannot be expressed in the form of p by q are irrational numbers.
Irrational.
So the combination of rational and irrational numbers are called real numbers.
Real.
Yes. So real numbers are the combination of rational and irrational.
Irrational.
Usually rational numbers are denoted by q. Combination is denoted by this symbol is read as union, and irrational numbers are denoted by q dash. So that r equal to q union q dash. In this chapter, we are going to start with Euclids division lemma. So what's the use of this Euclids division lemma? So let us
To find.
yes, Euclids division lemma will use to find the HCF of two numbers, right? HCF we can find in factorization method also, what we learned in the previous class. Here the new concept is introduced. We are using Euclids division lemma also to find the HCF of two numbers.
Yes, sir.
So Euclids division lemma. Given positive integer a and b, there exist unique integers q and r satisfying the condition a equal to bq plus r, where 0 less than or equal to r less than b. So the conditions must be written. Usually we'll write these shortcut form, the last two statements, but if you write the whole statement, I feel it's good. So let us see what is this. So to understand this a equal to bq plus r, let us recall the division algorithm.
Yes.
What is division algorithm?
Continuous steps, sir. Divisions continuous step.
In the previous classes you learned dividend. In the division,
Divisor quotient.
equal to divisor
Into quotient.
into quotient
Plus
Plus
reminder.
reminder.
plus reminder. It is based on that only. So here let us consider a as dividend, b as divisor, q as quotient, and r is reminder. So what will get it? In shortcut form, a equal to bq plus r.
BQ plus R.
So why this condition is given? Based on the condition whether the division is completed or not, we can find out. So suppose if you divide this 5 by 2, 2 times 4, right? Remainder is 1. Whether the division is completed or not.
No, sir.
Yes.
The reminder is not 0.
It seems
Reminder is
so. If you go to the rational numbers, it could not be complete now. So still further proceed. But here positive integers are mentioned. So when it is integers, we cannot take the rational numbers. So if it is, if when we could not take the rational numbers, we should check out how the division is completed, at which step the division has completed. So we should take the relation between the remainder and the divisor. So here the relation is given 0 is less than or equal to r less than b. Here r is remainder, b is divisor. Isn't it?
Yes, sir.
Yes.
So b is divisor, divisor is 2, and r is remainder, remainder is 1. 1 is less than 2. Is this condition is satisfied or not?
Yes, sir.
So the division is completed. That's it. So that only the condition is mentioned. Even remainder 0 also, 0 equal to remainder, r equal to 0 also can be taken. So that
Yes.
if even if it is 0 or less than divisor, the remainder is, then the division is completed. Right? Based on this division algorithm, we can easily find out a equal to bq plus r, where 0 less than or equal to r less than b. The condition is very important. Now, Euclid's division lemma and Euclid division algorithm we'll use in this concept. What is the difference between these two? It seems to be both also will be considered as same only. So, Euclid's division algorithm. So, while doing this, finding the HCF using the division lemma, what are the steps we are following? The process of finding the HCF of two numbers by using Euclid's division lemma
Euclid's.
is known as Euclid's division algorithm. So, as we know in the computer's algorithm means the process we are making in order, right?
The
So,
steps, sir.
HCF, while finding the HCF, the process of finding the HCF using the Euclid's division lemma is known as Euclid's division algorithm, right?
Yes,
Yes,
sir.
sir.
So, use Euclid's division algorithm to find the HCF of these two numbers. So, as we know that dividend is greater than the divisor. So, first let us recall the Euclid's division algorithm. So, what is it, my Euclid's division algorithm?
So A equal to BQ plus R. R is less than B
So, if you write
or equal to
both
B.
are positive, A and B, and Q are the statement, if you write, I feel it's good. But at least we should write A equal to BQ plus R, where 0 is less than or equal to R less than B. So, take the highest value.
So
So, the highest
225
value
equal
is
to A.
225. Divide with the least value. So, 135, least number. Now, can you divide it? How many times?
Yes, sir.
135
So one
times?
time.
One time only. So, 135. So, subtract it. 0. This is 7 plus 2.
So 9.
Isn't it?
Yes, sir.
That's it.
So 135 into 1.
Yes, ma'am. Now, we have to write the first step. Using this, if you want, you can write step 1, or directly also you can write. What is the step 1? Dividend what we have taken? It's 225. A
So
is,
225.
so we should write 225 equal to B is divisor. Divisor is 135. Into quotient. This is quotient 1
1, sir.
plus remainder is 90. So the first step is completed in this algorithm. Then go to the next step. So next step, here you can continue, or you can separately also write. It is your wish. So the divisor, we will take it as new dividend. So now divisor, take it as new dividend 135 divided by the remainder, take it as new divisor. This process will go on till the remainder comes 0. Is it clear?
Yes, sir.
So
Yes,
90
sir.
how many times? Again it is 1 only.
1 time, sir.
So what's the remainder? This is 5, this is 4, 45. So go to the next step. So in this second step is
So 135.
135
So 1
The 1 equal to
equal to
90
90 into 1
into 1
plus 45.
plus 45.
45.
This is the second step. Then go to the next step. What we have to do it next
So
step
90 equal to
The 90.
90 divided 45.
90 equal to 45 into 2 plus 0. Sir.
divided by 45. So keep it in mind, the divisor becomes dividend, the remainder becomes divisor till gets
Yes, sir.
0.
Yes.
Then it is 45 2 times 90. So the remainder is 0. When the
0.
remainder is 0, we can stop it. And
Yes, sir.
when the remainder is 0,
Sir, until we get 0, we should do it now, sir.
yes. When the
Yes, sir.
remainder is 0, then the divisor is called the HCF of given numbers.
Yes, sir.
So HCF is 45, sir.
That's it. Then go to the step 3. Is 90 equal to 45 times of 2
45 into 2
plus 0.
plus 0, sir.
Here keep it in mind, 45 is divisor, not 2. So when the remainder is 0, then the divisor is called HCF. So 45 is the HCF. Therefore, HCF of in the sense we can use the bracket. The numbers 135 and 225 is 45. That's the answer.
Yes, sir.
Yes, sir.
You all understand it?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. Same number of columns. What is the maximum number of columns in which they can march? So here
So
the
we have to find HCF.
yes. So by using this statement, we can say that we should find the HCF of these two. So let us find HCF of
So 616 and 32, sir.
yes, 616 and 32 using Euclids division algorithm. Euclids division algorithm. What is the Euclids division algorithm?
So A equal to
A
BQ
equal
plus
to
R.
BQ plus R.
BQ plus R.
R is less than 0 or equal to 0.
That
Less
condition is
than B or equal to
0 less than or equal to R less than B. Now find the HCF of these two. So again, go to the division. So which one we have to take dividend? 616.
Sir, 6,
Sir,
616,
616.
sir.
So let us take
16.
16 as dividend and 32 as divisor.
This divisor.
So divide it. How many times? How many times it is? So directly if you can do it, you can do it now. So if you separately divide it, what's the use of that? This normal division you can do it now. 32 ones are 32. So the remainder is, what's the remainder? This is 9 and this is
Sir,
2.
29.
20. So 296. 32 how many times?
Sir, 8.
8. 8 3 is a 24, 25. Not 8, 9 also is possible. 9 to
Yes, sir. 9288, sir.
That's it.
Yes.
So subtract this now. So this
Sir,
is
12.
ah,
Sir, 8, sir.
only that's
Sir,
it.
8.
So if you know that 32 19s directly, you can do it in one step only. If you do not know that, you can proceed this also.
yes, sir.
Yes, sir.
Now write the first step. Step 1 is
Sir,
equal to
616 is equal to
32
32.
into
So,
One-
19 plus.
19, sir, plus 8.
that's it.
So, 32 equal to 8.
Then go to the next one. So what we have to do the next step?
So,
Yes.
32
32 as the
32 by
32,
8.
sir.
divisor, take
8
it as
into 4.
the remainder, take it
8.
as divisor. 8 4s are 32.
32, sir.
32.
The remainder is 0. When the remainder is 0, we can stop it. The divisor
Yes, sir.
is
Yes,
called
sir.
its HCF. So let us go to the next step. So 32 equal to
Sir, 8 plus
8 times of
8
4
into
plus.
4 plus 0.
So when the remainder is 0, so the divisor is called HCF. Therefore, HCF of 616 and 32 is 8.
8.
So in how many columns they can match? Maximum.
8, sir.
Sir, 8 columns.
Therefore, they can march in 8 columns each. Is it clear to you all?
Yes,
Yes,
sir.
sir.
If anybody have the doubt, let me know. We'll discuss it.
Sir, no doubt, sir.
No, sir.
Right.